The FIA just changed the 2026 rulebook at the last minute. Top teams are now facing possible race bans and point deductions. Entire car designs could be scrapped, and we're only 12 months from lights out. This could flip the F1 grid upside down before a single lap is raced. Subscribe now if you want the full truth before the grid gets rewritten. Just as teams were finalizing their 2026 concepts, the FIA dropped a regulatory bomb that no one saw coming. With development timelines nearly locked in and design teams already shifting to production tooling, the FIA issued last-minute amendments to the technical rulebook, and the consequences could be catastrophic. These were not minor adjustments or clarifications. These were deep structural rewrites affecting key systems across energy deployment, aerodynamics, and component compliance. At the heart of the storm is a new set of restrictions on hybrid power deployment and active aerodynamics, two pillars of the 2026 regulations. Teams had spent over a year crafting highly integrated concepts around previously agreed benchmarks. Now, many of those benchmarks have been revised. Revised energy ceilings. Revised telemetry protocols. Revised safety mechanisms. In effect, the FIA is telling teams, start over or risk being illegal. That message couldn't come at a worse time. From the outside, it may seem like standard FIA tightening, but inside the paddock, the mood is different. This is the most disruptive technical update since the introduction of the V6 turbo hybrids in 2014. The difference now is that it comes when teams have already spent tens of millions designing to an earlier version of the rulebook. To many engineers, this isn't just technical interference, it's the regulatory equivalent of moving the goalposts mid-kick. And there's no appeal window. Several teams had already begun physical prototyping based on the older definitions, including core components like floor profiles, battery housing, and energy recovery control logic. The updated rules now force those components to be retested and, in some cases, re-engineered entirely. The knock-on effect? Delays in wind tunnel testing, blocked homologation requests, and millions in development costs suddenly written off. For factory-backed giants like Mercedes and Ferrari, that's frustrating. For independents like Haas or Sauber, it's potentially devastating. One of the most aggressive changes was the FIA's decision to hard-limit recovery energy through the MGUK to 4 megajoules per lap with no buffer allowance. Many teams had assumed a 10% tolerance, as had existed in previous seasons, to account for system inefficiency and calibration drift. Now, that tolerance is gone. That single change impacts battery sizing, cooling strategy, and even rear suspension geometry. In a hybrid era where energy is weaponized, this is a reset that cuts deep. Beyond the hardware, the real pressure may come from the newly mandated compliance layers. The FIA has introduced a telemetry-linked enforcement model. All override commands, DRS-style activations, and aero adjustments must be logged and traceable in real time. That means teams can no longer hide behind post-race data uploads or ambiguity in the regulation language. Any out-of-spec behavior, even momentary, becomes a basis for retroactive penalties. The trust dynamic between teams and the FIA just shifted dramatically, and not in favor of the teams. And all of this comes with no delay to the calendar. Pre-season testing remains scheduled for early 2026. No extensions. No grace period. Teams must adapt or risk arriving in Bahrain with illegal machinery. The FIA is enforcing its authority in full, and whether you believe it's justified or reckless, the message is loud and clear. The rulebook is not negotiable even when it arrives 12 months before the green lights. One of the most immediate effects of the last-minute regulatory changes concerns energy deployment limits. The FIA has now enforced a hard ceiling of 4 megajoules per lap on MGUK energy recovery with zero tolerance for fluctuation. Previously, teams were allowed to operate with a flexible buffer of up to 10% to account for system variances and thermal drift. This seemingly small change reshapes the entire electrical architecture of the car. Engineers must now redesign energy maps to ensure that the powertrain does not exceed even a single kilojoule under race conditions or risk post-race penalties. The active aerodynamics package has also been revised under the new rules. Each movable surface front wing elements, rear wing flaps, and any interconnected components must now operate with built-in fail-safe redundancies. That means dual actuator systems, secondary power backups, and strict G-force compliance under braking and yaw. This change dramatically increases both complexity and weight. Some lightweight aero packages, already in advanced stages of validation, are now non-compliant because they lack this redundancy. For teams like Aston Martin and McLaren, that means returning to the drawing board. Another overlooked but deadly serious update is the floor stiffness requirement. The FIA has introduced a new vertical load protocol, specifically designed to replicate the pressure exerted when a car strikes a high-speed curb or rides a street circuit bump. Any flexing beyond the updated threshold, even momentary, is now grounds for disqualification. This directly threatens the development paths of multiple teams who had pursued aggressive underbody geometries to maximize ground effect. And with CFD simulations no longer sufficient on their own, real-world flex tests must be passed before the first shakedown lap. Fuel delivery systems have also come under tighter scrutiny. Under the revised combustion standards for 100% sustainable fuels, the FIA now requires consistency in thermal efficiency output under variable ambient conditions. That means injector timing, spray pattern stability, and temperature response must remain within newly defined windows across the full race cycle from cold start to peak race pace. Ferrari and Alpine had been developing proprietary injector tech that relied on transient variability to extract marginal gains. Those systems may now be classified as non-compliant due to the updated uniformity criteria. Software logic is also in the spotlight. With override systems becoming more complex, especially those used to control energy recovery, braking force modulation, and active aero toggling, the FIA is now demanding line-by-line review of any code that interfaces with a regulated system. That includes firmware on ERS units, actuator controllers, and central telemetry transmitters. One team, believed to be Red Bull, was flagged for using a conditional logic tree that allowed manual override under a gray area in battery state thresholds. That kind of code is now banned. And the scary part? Violations can be detected after a race and punished retroactively. The FIA's new compliance regime doesn't just punish mistakes, it penalizes assumptions. Several teams had banked on performance under interpretations of the previous regulation text that were, while not illegal, built around exploitable ambiguity. That's now gone. The language has been tightened, the enforcement has been made immediate, and the tolerance for clever loopholes has dropped to zero. This shift disproportionately impacts the most aggressive engineering departments, the very ones that thrived under looser interpretations in 2022 and 2023. In summary, what we're witnessing isn't just a list of regulation changes. It's a comprehensive deconstruction of the foundation on which 2026 cars were being built. Everything from front-end geometry to ERS deployment logic to crash structure materials is being re-evaluated in real time. And any team that proceeds without adapting to these revisions is not just risking a lack of performance, they're risking full disqualification from the championship opener. Inside every team headquarters right now, from Brackley to Maranello, alarm bells are ringing. The FIA's late-stage regulation changes have thrown engineering timelines into disarray. Development calendars built months in advance are now obsolete. Simulation data previously used to lock in component architecture must be rerun under new constraint models. There's no time for theoretical fixes. Teams must now prove every physical behavior through dynamic validation or risk being denied homologation before testing begins. One of the greatest challenges lies in remapping the energy deployment system under the new hard cap of 4 megajoules per lap. With no tolerance band, teams must achieve absolute precision in how the MGUK charges and discharges energy. This isn't just a software problem, it's a thermal, mechanical, and electrical integration nightmare. The inverter must maintain peak efficiency within a narrower thermal range, and any heat imbalance can trigger output loss or, worse, illegal overboosting. Engineers are now battling to tame systems that were designed under entirely different thermal load profiles. Aerodynamics departments are equally under pressure. The requirement for dual fail-safes in active aero systems forces redesigns of the front and rear wings, and even the underfloor airflow management. The packaging constraints alone are suffocating. Backup actuators, secondary hydraulic loops, and control feedback redundancy must now be integrated into spaces that were already crowded with energy storage and suspension geometry. The irony? Many of these changes add weight, undermining the 2026 philosophy of lighter, more agile cars. On the structural front, things are even more delicate. Revised stiffness protocols for the floor and front crash structures are now pushing material science to its limit. Several teams had adopted composite blends optimized for flexibility under normal load and rigidity under impact. But under the FIA's new vertical load testing, that balance fails. Sudden deformation, even if within safe racing parameters, is now non-compliant. Teams must now explore alternative fiber weaves, structural foam densities, and reinforcement ribs with just months before design freeze. Then comes the software architecture, the new frontline of F1 engineering warfare. Under the FIA's revised telemetry compliance system, every system that affects performance must now report in real time, including override logic, battery charge rates, and aero activation timing. This leaves no room for proprietary logic trees or exploitative gray code. Teams must hand over their control software line by line for inspection. And once submitted, that code is locked for the season. Any change requires reapproval. One misstep, one undocumented override, and you're sanctioned retroactively, even if the car finished the race clean. Midfield teams are especially vulnerable. They don't have the luxury of burning entire prototypes to adapt. They're forced to choose between reacting fast or playing safe. For outfits like Williams and Sauber, a single rejected component can derail not just performance but funding, partner confidence, and internal morale. These squads operate on the edge of viability. Every redesign they're forced into due to last-minute rule changes pushes them closer to a financial and competitive cliff. All of this means that engineering success in 2026 will not be defined by the boldest idea but by the most adaptable system. Regulation has now become the first lap. Teams that treat compliance as an afterthought will not just be slower, they may not even be allowed to race. In a world where software governs energy and safety governs speed, Formula One in 2026 won't reward who builds the fastest machine, but who builds the smartest, most lawful one under fire.